today we're going to talk about how to multiply polynomials. You actually already know how to do this. So the first thing I want to show you is just review. But when we multiply these two polynomials, x plus 8 and x plus 3, FOIL is the method that we often talk about. It's that first, outside, inside, last. I'm not a huge fan of that terminology, but it'll work for what we're doing. So if we want to multiply these things, we take this x times both of those things. So we're basically distributing the x to both of the terms in the second parenthesis. So we get x squared plus 3x. And then we distribute the 8 to both terms over there. So we get 8x and 24. And then we just combine our like terms. So 3x and 8x are like terms. And so that's our answer. And we know how to do that. You may have also seen another method called the box method. And it's another nice way to organize this. So I don't know if you're a fan of the box method, but what you do is you take the first polynomial, x and positive 8, and we write that across the top of our box. And then we do the second polynomial on the side of the box, x and 3. And then it's like a multiplication table. So we do x times x, which gives us x squared, x times 8, which gives us 8x, 3 times x gives us 3x, and 3 times 8 gets us 24. And the nice thing about the box method is often, not always, but usually your like terms are on the diagonals. So this is going to give us x squared, and then those like terms, plus 11x, plus 24. So the exact same thing we had when we did the FOIL method. It does not matter to me which method you use. I'm just going to show you some different ways that these can be used, and maybe you'll find one that you like better. Again, I don't care if you FOIL stuff or if you use the box method, as long as you do something that gets you a right answer. Now, we are going to do something more advanced because that previous slide, that's completely like junior high stuff. We're in Algebra 2, so we might have something like this that we need to multiply. So we can use the distributing method. You're going to see there's some downsides to this, but let's start it out. So basically this x squared gets distributed to all three of those things. So we get x to the 4th minus 5x cubed plus 2x squared. And then the 3x is going to get distributed to all three of those terms. So we get 3x cubed minus 15x squared plus 6x. And then finally, the 1 gets distributed to all three of those things. So x squared minus 5x. Oh, we're running out of space. Plus 2. Squeeze it in there. Okay, so it's still the idea of foiling. It's like super foiling or something. But it's just distributing. Everything in the first polynomial gets distributed to everything in the second polynomial. And then we combine our like terms. So x to the 4th is all by itself. Those are the x cubed terms, so negative 2x cubed. Here's the x squared terms. There's 3 of them. So let's say minus 12x squared. Here's the x terms, and then finally the 2. Now, the disadvantage to this is you have to kind of hunt around for your like terms. So process-wise, it's fine, it makes sense, but it's sometimes hard to find all of your like terms. So this is an instance where the box method is really, really handy. So I'm just going to redo this problem using the box method and show you what I mean. Just ignore those blue lines up there, no big deal. Okay, so for the box method, we're going to take the first polynomial and write those up here across the top. We're going to write the second polynomial down the side. That's a negative 5x and a 2. And then we'll create our box. So this time it's a 3 by 3 box. And I'm going to start across the first row. X times x squared is x. Oh, no, I wrote that down wrong. That's an x squared. Glad I caught that. X squared times x squared is x to the 4th. X squared times 3x is 3x cubed. X squared times 1 is x squared. Second row, negative 5x times x squared is negative 5x cubed. Negative 5x times 3x is negative 15x squared. Negative 5x times 1 is negative 5x. And last row, I get 2x squared, 6x, and 2. And again, usually the like terms are on the diagonals. So there's only one x to the fourth. And then here's our x cubes. So negative 2x cubed. Here's our x squareds. So negative 12x squared. Here's our x's, and then plus 2. So again, it does not matter to me which method you use. If you like to do the big distributing thing, great. If you'd rather use the box method, that is totally fine too. In the next video, I'm going to show you one other method you can use if you like. We'll check it out in the next video.